Welcome to this section of the course. We'll be covering chapter 7 of the A2 level book. In this chapter, we'll look into derivation of the addition and subtraction formulas for sine, cos, and tan, using the addition and subtraction formulas and derivation of the double angle formulas, solving trigonometric equations with them, and verifying questions such as constant multiplied by cos and adding and subtracting another constant multiplied by another angle. So we'll be covering things there is to know for trigonometric metric equations and identities are also applied for in integration and differentiation chapters. So this chapter is quite important because these identities will help you also solve some of more complicated calculus problems. So let's get it started. As always, I always encourage my students to have a go at the preliminary questions, or rather or prior knowledge questions at the beginning of each chapter. So I encourage you to pause the video here and have a go at these problems yourselves, and I will show you how it's done in a few seconds. Okay, so I hope you've had a go at these questions. The very first question is a basic calculator problem. You just testing you so that you know whether to use your calculating degrees mode or radians mode. So sine of 45 degrees, cos of pi over 6 is in radians, so make sure you put your calculating radians before you do that, and tan of pi over 3 is simply root 3. Okay, so question 2 is rather more complicated, rather more involved, I should say. So I encourage you to think carefully about the range before you get started. Okay, so what we'll have to do is look at the domain here. Inside the bracket we got x plus 50. So what we have to do is say, if I have x plus 50, that means that I need to find my answers between 50 degrees and 410 degrees. Basically, because here I added 50 degrees to x, I'm adding 50 degrees to both sides of this inequality. So then what you can do is use your calculator. These answers are in degrees, so make sure your calculator is in degree mode, and you take sine inverse of a negative 0.9, and you'll get an answer such as, well, we write sine inverse of negative 0.9 to be x plus 50. I would leave x plus 50 on the left hand side, and the very first answer is not within the range that we want. It's, in my calculator, gives me negative 64.1. So what we have to do is think about the sine curve. Sine curve repeats itself every 360 degrees, and what we have is this would be the 0 degrees here and negative 64. So it would repeat itself over here. So however much we went back from 0 degrees, we go forward from 180 degrees. So we can say the formula is basically sine of theta is sine of 180 minus that angle. So in our case, our theta is negative, but the formula still works. We say sine of negative 64 is the same as sine of 180 minus a minus 64. So that would add it up for us. And also another answer would be 360 plus negative 64. So if you go ahead and add uh, the, well, just say 180 plus 64.1, that would give you the first answer, and 360 take away 64.1, that would give you the second answer over here. So that it falls within the range that we want. And those two answers are 194.2 and 245.2. If I get rid of my handwriting here, that would be how you figure out that answer there. Okay, so for the next question, part B, we have the range to be 2x minus 30. So you build this equation up. You say first we double the x value. So we're going to double everything on the left and right of this inequality. And the next step is 2x plus, we take away 30. So if we take away 30, from 0, you'll have negative 30, and take away 30 from 720, you'll end up with 690. So we need to make sure our range of answers fall between these two numbers. So then we take inverse of a half. Sorry, I just recognized that we got that x plus 50 was those two values, and the final step of the previous question was subtracting 50 from there. Hello and welcome to this section of the course. We'll be covering chapter 7, trigonometric and modeling, in which we will derive the addition and subtraction formula for sine and cos. This particular chapter is very important because the identities that we will derive in this chapter are also highly used in the calculus and dealing with derivatives and integration of trigonometric functions. So make sure you pay particular attention and you learn their formulas and you understand how to use them and apply them. Alright, so let's get started. As always, I always encourage my students to solve the preliminary questions that each chapter has as prior knowledge test to make sure you understand, you know what is the prior knowledge that's required. The first question here is basically checking your understanding to see whether you know how to use your calculator and make sure your calculator is in the right mode for the right answer. The first question is in degrees, so you answer that with the degrees mode on your calculator. You sine of 45 degrees is root 2 over 2. Cos of pi over 6 is cos of 30 degrees, which is root 3 over 2, and tan of pi over 3 is tan of 60 degrees, which is simply root 3. Right, so next question is rather more involved. We have to make sure our calculate where we look at our range of inside the bracket. Sine has x plus 50, so you adjust this range. We say that we added 50 to this x, so we have to add 50 to left and right hand side of this inequality, and we are going to go and find our answers. First of all, to be between 50 and 410, because that's basically, if you think about the sine curve, it has been translated to one direction by 50 degrees, and that's why we will have to do this calculation as such. So x plus 50 degrees will be sine inverse of negative 0.9. Now When you put that on your calculator, you end up with an answer that's negative 64.1, and this is obviously not even within the range that we want. But if you think about the sine curve, one way to think about it is that our answer is down here at negative 64 and 0 is here. So the the answers that we should get are we can use our trigonometric identities. Sine of theta is equals to sine of 180 minus theta. Now in our case theta is negative, doesn't matter. We can use the same formula. Sine of negative 64 is the same as sine of 180 minus a minus 64. So that means 64.1 actually. That means that we add 64.1 to 180, and the first answer that it's equivalent to, it's not equal to, but equivalent to is 244.1. Now also there is, so this is where 244 comes from. The other answer is we found this number here. Now the other number is simply just 360 plus, in our case theta is negative, so 360 take away 64.1 will leave us with 295.9, I guess. So let me just double check that on my calculator. 360 take away 64.1 is, yes, 295.9. So, but our work is not quite done yet, because we have got x plus 50 to be these two numbers. So our final derivation involves taking 244.1 and subtracting 50 from it, and also taking 295.9 to and subtracting 50 from it. And what you will end up with is those two numbers that popped up on the page, 194.2 and 245.8. Now there is a rounding correct to one decimal place, which if you actually do it correctly, you will get these two answers. I rounded up my number here to 64.1. It's actually should have been 64.2, but that's just a small adjustment. The process remains the same. So make sure you adjust your range here, and you go ahead and you calculate all those values between this range. And first answer was negative, and we had to adjust it. So the trigonometric identities is one of them for sine is this, and the other one, obviously you can always add 360 to your answer and subtract 360 from your answer to adjust the range. Now the next question is got 2x minus 30, so I'm just gonna rub this bit off because we want to write a new range for the other equation there. So I do it with a different color pen. Here, first you will do one step at a time. First we're gonna multiply up by 2 the left and right hand side of this inequality, and then take away 30 from that. So taking away 30 from 720 will leave us with negative 30 on the left and 690 on the right. So degrees. So we need to find our answers to be within this range. Now when you take cos inverse of half, what you end up with is cos inverse or arc cos of a half, I believe, is 60 degrees. Let me just double check. Yes, it is 60 degrees, but this is our one of our values with cos. The cos identities are cos theta being equal to cos of 360 minus theta. That's because is symmetric around 0 or 360 degrees. So this is that means that cos of 60 is the same as cos of 360 minus 60. So basically, the other answer, the other principal value is 300 degrees that we will store here for now. Now, all we have to do, we found the very first two principal values. We have to add 360 to each of these answers because our range is extended and doubled. So and first of all, actually it does go to negative 30, but I know taking away 360 and going back from these two answers is gonna overshoot the range, so or rather undershoot the range. So the only way is going forward, adding 360 to 60 will leave us with 420, and adding 300 and basically adding 360 to each of these answers. So we have 300 plus 360, which leaves us with 660. That is just under 690, which is fine. Now, we're not quite finished because what we found here is that these four answers are 2x minus 30 degrees. We want to solve for x. So the first step, just like solving an equation now, is to add 30 to both sides of this equation. So we will have 2x being equals to 90, 330, and 450, because I'm adding 30 to each of these values here, and finally 690, and this is still 2x, so we need to divide these answers by 2 to get an x. We'll have 45 degrees and 165, I'm guessing, and then 50 divided by 2 is 225 degrees, and 90 divided by 2 is 345. So this is our final answer where I'm underlining. So I'm gonna write the next question with a different color. Let's choose green here. So this is looking like a quadratic equation that's has got coefficient of x is 1, so I don't need to adjust the range. I'm gonna just look for answers between 0 to 360 degrees there. So if I write this as 2s squared minus s minus 3, you'll see quadratic equation easier. If we can factorize that to the 2s here and s here, and I need to multiply to negative 3, so I'm going to actually put a minus 3 and a plus 1 here, so that my answer will make sense. So when I multiply this out, I'll have positive 2s minus 3s will give me minus s in the middle. So if you're not sure, you can also use your calculator to get this answer. Solving this will give us sine to be, let me just write it here, sine of x to be 3 over 2, positive 3 over 2, which is impossible to have. So we'll discard that answer. Sine of x here will be minus 1. This does have an answer, so x will be sine inverse of the minus 1, which is 270 degrees. Now that falls just at the trough here. So this particular value doesn't have any alternate answers for sine. You can check for yourself as well, because the graph is symmetric at 270 and 90 degrees. These two values are where at the top and the bottom of the unit circle. So this is where 270 is. That's why adding or subtracting anything from it will not give us any alternate answers. So this is the one and only value that falls between 0 to 360 degrees. Okay, so we can leave question 2 now and move on to question 3. Question isn't really challenging. You start with left hand side and adjust to trigonometric identities. Can be written as sine over cos. So we have this fraction, and we can see that on top of this fraction we have sine square, and if we want to add cos to this, we need to multiply cos by cos so that we have a common denominator. So here I'm multiplying top this fraction by cos over cos of x. So on top of it, we'll have cos square of x. In the denominator, we'll have a single cos as a common factor now, and then we have sine square on top of the next term. I've just summarized this over one denominator. So we know that cos square plus sine square is a 1, and our final answer is going to be 1 over cos, which simply is what sec, the definition of sec. So that is the right hand side. So that ends that portion there. So cot is reciprocal of 1 over tan, which is cos of x over sine. Sec is 1 over cos, and sine I can leave it as sine on top of the fraction, because I will see that these cancellations will help us prove that they all leave a 1 behind, so that identity is equals to 1, which was the left hand side equals to the right hand side. So that is done. Now again, for part C, is cos square plus sine square is 1, and 1 over, I'm going to write cot as cos square over sine square. And in the denominator, we can get a common denominator and rewrite that 1 as sine over sine square over sine square, because here we have the denominator is sine square. So let's just leave the 1 there. I'm going to have sine square of x plus cos square of x here, all over single sine square. And we know that this fraction has sine square plus cos square famous identity, it's equals to 1. Therefore I have 1 over 1. Oh, again in the denominator I have 1 over sine square. Now it simply means that this bottom of the bottom flips up and it comes to the top. Basically 1 multiplied by sine square over 1 is simply just sine square, and you can see on the right hand side of that equation that's what it is. Okay, so that is left hand side. Okay, so this preliminary knowledge check is done. So I'd like to pause the video and we'll take a break, and I'm going to jump straight into the first section of the chapter 7.